Hi guys, welcome to Pilot Labs. My name is Chirag Dhal, and in this video today we are going to have an introduction to IPv6 addresses. Now the question is, why IPv6? So if I talk about the reason behind this, why do we actually talking about IPv6, then the simplest answer to this is that we don't have IPv4 addresses. So we have been discussing about various things related to IPv4 addresses, but now we are almost out of it. So you can calculate the total number of IPv4 addresses by calculating 2 raised to the power 32, which is the number of bits in your IPv4 address, and this particular calculation will give you a value something like this: 4294967, 296. So this much of IP addresses were available to us from the IPv4 category, and using these we have been doing practices related to VLSM, private addressing, network address translation. Now the designing of this IP version 4 was done 30 years ago. So it was done back in around 80s, at the end of 80s or the beginning of 90s, right? Now the creators had no idea that how internet would be as large as it is today. So they tried defining a reliable system for providing the IP addressing, but unfortunately that were not enough to we can say fulfill the requirements of the generation, or we can say the internet generation which we have today. Everyone, I would say every individual today has at least 2 to 3 devices which requires IP address, right? So there is a huge demand of IP addresses, and since we were out of IPv4, so we decided to transition to IPv6. Now, talking some more details about IPv4, we can say IPv4 was controlled and distributed by the organization INA. INA stands for Internet Assigned Numbers Authority. INA, with the help of some regional registries, was taking care of providing the IPv4 addresses. Now it's time to learn about IPv6. So let's also talk about IP version 6. So the very first thing to know about IP version 6 is that it is 128 bits address. We can say every additional bit here is doubling the possible addresses. So every additional bit doubles the number of possible addresses, and they are available in a very huge range. So we have trillions and trillions of IP version 6 addresses, and I can give you the guarantee that we will not face any limitation of using IP version 6 addresses in coming days. I mean, not in the near future. So if I talk about an example of how IP version 6 looks like, so it's going to be something like this. You must have seen it by now. So we can say it will look something like this, where we have 8 groups containing different values. So let's say my address is this DB8000A, for example, colon 001B, colon 20A5, colon 0020, colon let's say 34AB. Now let's say this is my IP version 6 address. Okay, I think there is one less group. Yeah, so I'll add one more group, 20A1 here. So there are 8 groups which we have, and this is how your IP version 6 address will look like. Now there is a process of shortening the IP version 6. You don't have to write down the whole address every time. There are few techniques which you can use to shorten down the IP version 6 addresses. Now these techniques include some rules. So the very first rule is that you can ignore the leading zeros. So in any particular field, if you have a 0 in the beginning, you can ignore that. So basically we can say we will write this address in a shorter way by ignoring the leading zero. So it will become 2001 colon. I can avoid this 0 and can directly write down DB8 colon. Then again I can avoid these 3 zeros and can simply write A colon 001B. So I will write 1B only colon 20AF A5, I'm sorry, 20A5. I cannot remove this middle zero. It should be in the beginning only. Then only you can say that you will be you can basically remove that particular zero. Then for this field I can write simply 20 and then 34AB and then 20A1. So that's how basically you can shorten it down. Now there is another way of shortening it down by replacing a quarter of all zeros by a double colon. So if you have consecutive quarters of all zeros, or we can say if you have a field of all zeros, then you can remove that field and can put a double colon there simply. So let's take another example and let's try to understand the second rule of shortening the IPv6 addresses. So for example, let's say now the IP which I have is 2001 colon a series of zeros. So 0000 colon 0000 colon 0000 colon, then I'll write some values, 20A1 colon again 0000 colon 0000 colon, let's say 12AB. So what I said earlier was I can remove consecutive quarters of zeros and can just simply put a double colon in the place of them. So I can see that there is a series of zeros here. So instead of writing them, I will put double colon. So my address will become 2001 double colon, then 20A1 colon 0000 colon 0000 colon 12AB. Now you all must be wondering that why didn't I remove these series of zeros, or why I have written all the 8 zeros here, why didn't I put double colon again for them? So the reason is that this can only be done once per address. So you cannot do it for 2 times or 3 times for any particular IPv6 address. You can only do it once in any particular IPv6 address. So if you are removing these zeros and writing a double colon in the place of them, then you cannot do it again in the same address. But there is another way of making it a little more short. So that is ignoring the leading zeros. So I'll write it like this, 20A1, and instead of writing all the 4 zeros, I'll just simply put a single zero, then a single zero here, and 12AB. So that's the shortest way of writing this particular IPv6 address. That's how basically you can shorten down any particular IPv6 address. And in the same way, you can also expand the IP version 6 addresses. If let's say I provide you something like this and ask you to expand it into its original form, then you can do the expansion using the same rules and the same tricks. So this was all about managing or writing down the IPv6 addresses. Now the next thing is that how IPv6 actually look like in the case of the distributions. So I said earlier that we put slash values with the IP addresses. So if I'm putting /64, that means that the first 64 bits are going to be a part of network side and the remaining ones will be the part of host side. So let's try to break down the IPv6 address on the basis of network and host distributions. So talking about a particular enterprise requesting IPv6 addresses from their ISP, they will usually receive a /48 block. Then if I talk about IPv6 subnets, then they are usually /64 with the prefix length of /64. That means an enterprise has around 16 bits to make use of the subnet, and the remaining 64 bits can be used for the host part. So it might sound a little confusing, but when we will write it down on the screen here and we'll try to understand it again, then you will get a better understanding of this. So out of the total 128 bits, I said that an enterprise would be receiving /48 from their ISP block. That means the 48 blocks will be used, or we can say will be assigned to you by your ISP. So the first 3 groups contains the 48 bits. Each group is of 16 bits. So if I am writing an IPv6 address like this, 2001:0db8, then let's say 1A00, then up to this 1A00 part, all these values will be provided to you by your ISP. Then I said that this will be provided by ISP. Then the next thing I said earlier was that 16 bits will be used for making the subnets. Okay, so /16 will be used for the subnets. That means my next group after this column, let's say for example 003, this particular value is going to be used by the enterprise for making the different subnets. So these 16 bits are called subnet identifier. Subnet identifier. After that, the remaining part of your address, which is going to be of 64-bit, that particular will be called as interface identifier and is basically the host portion of the address. So we can write it in a way like this, that it will be 0000:0000:0001. So we can say this whole part, or the remaining 64 bits, are your host part, which is known as interface identifier. So that's the distribution of a particular IPv6 address. I'll repeat myself. The first 48 bits will be provided to you by your ISP. The next 16 bits are used for creating various subnets. Then the last 64 bits will be used for the IP addresses. Now this was when the slash value is 64. So that's how it works, and that's how in any particular IPv6 address you will be able to find out that what is the network part and what is the host part. So this was all about IPv6, and now we are going to have a look into how IPv6 is configured. So let's have a look inside the packet tracer by creating a little topology. So I'm going to take a router here. I'll place a router, then I'll place 2 switches, and I'll connect some end devices like this. Let's make the connections. There you go. So the IP address I'm going to configure on the FA00 will be 2001:0:1:1/64. Okay, I have written some IP address. Let's try to expand this. So the first thing I have is 2001. Okay, that's correct. In the next column, I have DB8. That means it must be 0DB8. Alright, column. Then I just have a single 0. So let me expand it to 4 zeros, as I know that I ignore the leading zeros. Column. Then I have just a single 1. So it should be 0001. Cool. Column. After that, I have double column. Then at the end, I have 1. So double column means that I have consecutive quarters of zeros. And how many quarters are we left with? We are left with 4 quarters. So 1, 2, 3, 4. This is going to be my first quarter. 1, 2, 3, 4. Second. 1, 2, 3, 4. Third. 1, 2, 3. And then at the end, we have 1/64. So basically, if I expand this particular address, then it will look something like this. And this IP is something which I'm going to configure on interface FA00 here. Then from the same network, I will provide the IP address to my PC0, which is going to be 2001:DB8:0:1:2/64. So :1 I used for FA00, that means 00001, and :2 is something which I'm using for PC here. That means it will be 0000, and at the end we will have 2. Alright, then similarly on the other side I will use a different network. I'm going to use 2001:DB8:0:2:1/64 for FA01. Then if I talk about PC1, then it's going to be :2 as the value. So let's get started. Let's see how this configuration will be done and if my devices will be able to communicate after that or not. So first of all, I'm going to configure the router. Here's my router. I'll go to the CLI, say no to the question, say enable config T, host name R1, interface FA0/0. Now earlier for configuring IPv4 addresses, we had the command IP space address, then we used to put the IP address. Now this time we will have to say IPv6 space address, then put the address. So my address is going to be 2001:DB8:0:1:1/64. Enter. Okay, it says there is some issue. Alright, so I was not in the interface configuration mode. I'll go to interface FA00 again and we'll run the same command again. Now it got executed successfully. No shutdown to make the port up. Perfect. We have configured FA00 successfully. Now I'll go to PC0, desktop. In the IP configuration, I have this section of IPv6. I'll configure the IP address here. 2001:DB8:0:1:2/ will be 64, and the gateway address will be 2001:DB8:0:1:1. That's going to be my gateway, which is the IP address I have on the router. Now let's put the configurations on FA01 of the router 0. So interface FA0/1 IP address, or instead of that I should say IPv6 address 2001:DB8:0:2:1/64. Enter, and then say no shutdown to make the port up. Then close the window, go to PC1, desktop, IP. Here I'm going to put the IP address 2001:DB:0:2:2/value will be 64, and the gateway address will be 2001:DB8:0:2:1. That's going to be my gateway. Close this, go to PC0, go to command prompt, and here I will say ping 2001:DB8:0:2:2. Enter. When I try to ping this IP address, let's see what do we get as the result. So my first packet got dropped. Okay, second packet also got dropped, and if I let's say fast forward this, then all my packets are getting dropped. The communication is not getting successful. It is failing. And the reason behind that is we haven't enabled the routing process on this router as of now. Yeah, we didn't have to do this earlier in IPv4, but for IPv6 you have to enable it. So go into the configuration mode and say IPv6 space unicast routing. Enter. After this, if I go to PC0 and try making the communication again, there you go. We are receiving the replies and the devices can communicate. Now let's try to look at some show commands which we can use for checking the details of IPv6. So in order to check the routing table, you just have to say show IPv6 route, and this will print out the routing table. Similarly, in order to check the IPv6 addresses which you have configured on the interface, you can use the command show IPv6 interface brief, and it will give you the details related to IPv6. So that was all. These were the few things which we had to talk about in the section related to IPv6. I hope you guys were able to understand whatever I have delivered here. So again, I'll go through some of the basic things. That IPv6 is of 128 bits. It is usually written in the hexadecimal form, is being used nowadays because we are out of IPv4 addresses. It is available in very huge numbers, so we don't observe technologies like network address translation here. Then it supports various routing protocols like you have learned, like probably you'll be learning later on in the course about OSPF, EVE-NG. All of them have a version related to IPv6, so we can work with them. It is very easy. Once you get a command of IPv6, you can basically easily transition to it. So try practicing the topology which we have discussed here. Try adding some more differences, try adding a little more devices, some more PCs, maybe a little more routers, and see how and if you are able to work with IPv6 or not. So that was all for this video. Thank you so much. I hope you enjoyed the video. I'll see you in some other video. Till then, take care. Bye-bye.